Today we are starting our new unit on exponents and powers. The first thing that we're gonna kind of review real quick here is just what is a power. Okay, so there's two parts to a power. So the first part that you have represented by the A here is called the base, and then the next part that you have represented by the n here, that's kind of in a superscript. That's your exponent. Okay, we've seen this before where the base indicates what number is being multiplied, and the sorry and the exponent means how many times you're multiplying it by itself. Okay, so like when we're doing this, when we are doing this with, we've seen this with what formula have we seen it with? C equals, not C, sorry, but if we're looking at the area of a circle, right? Area of a circle, we're looking at pi r squared. That's the formula for area of a circle. Area of a circle is pi r squared. Well, in that, we're multiplying r times r. Okay, that's one of the places that we've seen this before. So thing that's going to happen now that we're moving on to this year is that we are moving from just having things like numbers squared to numbers that have exponents going up to pretty much infinite. We could do that, but we're not going to. We are going to also start having our base be negative numbers, so we're going to be dealing with that as well. So just looking right here, when we're talking about this is an example from your, it's a clip from your textbook. So when an integer other than 0, okay, that's important, can be written as a product. So product, we're talking obviously about multiplication. Okay, of equal factors, so it's always the same factors. We can write the power as the integer as a power. So for example, 5 times 5 times 5 is 5 to the 3. Okay, 5 to the power of 3, or 5 to the third. So 5 is the base, 3 is the exponent. So 5 to the 3 is what's known as the power. Okay, and then 5 to the 3 to the power of 3 is or 5 thirds, 5 to the third or 5 cubed, okay, is a power of 5. All right, so if we were to do that, remember it's 5 times 5 times 5, so this gives me 25 times 5, which is equal to 125. So 5 cubed is equal to 125. And we're going to talk about how to put these into your calculator and stuff, but one of the biggest things that you have to remember is that you're multiplying always this base by itself, and the number of multiplications or number of times you multiply it by itself is determined by the exponent. Just a little bit more about powers and things. Power with an integer base and exponent 2 is a square number. Okay, so the place that we've seen this the most, like I said, is in that idea of pi r squared. Okay, or the area is equal to the area of a circle, right? So we have that square number. So when the base is a positive integer, we can illustrate a square number. So here are 3 ways to write 25. Okay, so we have this as the standard form 25, and this term standard form is going to become pretty important in this. It's when we talk about the standard form, we're talking about the response to a power. Okay, so the power is 5 squared. The repeated addition is 5 times 5, but the standard form is 25. So if it asks you to find the standard form of 5 squared, you're going to say that is 25. Okay, so over here we have this grid. We've seen enough of these grids. The side length is 5. It's a square. 5 times 5 equals 25. Okay, so it's a square number. If we have an integer base, okay, so it can be any integer, and the exponent is 3, this is what we call a cube number, okay, and this creates a 3D shape. So we can illustrate a cube number when it has a positive integer. So again, we have, I don't like, this is again a clip from your book, and I'm not a huge fan of how it's written here. I would have preferred it as talking about the power first, okay? So the power is 5/3, or 5 to the 3, okay? The repeated multiplication is 5 times 5 times 5, right? That's very important. It is not 5 times 3. No, that's a no. We're not doing that. We're multiplying the base 5 by itself 3 times, okay? And that gives us a standard form or an answer of 125. So again, it is kind of that, change color here, it's kind of that idea of we have a cube, okay? So we have 5 times each, the cube is 3-dimensional, right? And it is 5 times 5 times 5, okay? So again, that's why partially when we're doing volume, it's always in units, let's say meters cubed, is because it creates this, okay? Area is always squared, but volume, we're going to get meters cubed. And so we're going to move on. Like when we're doing this, we're going to have powers that are higher than 3, higher than 2. We're going to get powers that are more than that. But this is kind of the basis. The basis stays the same. We have the power. We can write it as a repeated multiplication. And then from there, we move on to standard form. So as we keep moving on, so we get a little bit better of a definition of power. So it's an integer other than 0 that can be written as a repeated multiplication of an equal product, okay? So what does this mean when given a power? The base, okay, the number that, remember in the base was the a, okay, is being repeated, is the number being multiplied, and the exponent, okay, tells you how many times. So that n value that we had, or that n that we saw, okay, that's how many times. That's your exponent, okay? So if I'm looking at this first one, in my exponential form, my power, I have 4 to the power of 7, okay? So my base in this case is 4, and my 7 in this case is the exponent. So what I would do is I go 4 times 4 times 4. Okay, that's 5, 6, 7. Okay, we're not going to talk about the standard form or the answer right at this moment, but we're going to keep going with that. So again, in this one, the base is 3 and the exponent is 5. Okay, so 3 times 3 times 3 times 3 times 3. Now, in this next one, it's really important that this negative integer is between the brackets, okay? We're going to talk, but if it was negative, if it looked like that without the brackets, that changes what we're doing there, okay? That changes what we're doing there, and we're going to talk about that shortly, but that changes what we're doing there. So in this case, the base is that -4, and I'm going to keep it in those brackets right now, and that's going to be super duper important in a minute here. So, okay, my exponent again is 5, and so I have -4 times -4 times -4 times, you'll notice I'm keeping all the brackets. In grade 8, I talked to you guys about brackets being important, and we're going to really use them really well right now, okay? So that idea of base and exponent, we need to be able to identify those. We talked, this is a little bit just what a question might look like, okay, right here from your book. You know, it might ask you to write as a power, and here we have a repeated multiplication. We have 3 times 3 times 3 times 3 times 3 times 3. So we have 1, 2, 3, 4, 5, 6. So when there's 6 equal factors, okay, and the exponent is 6. So that's why it writes it as 3 to the power of 6, sorry. Here for B, we just have 7 by itself. The base is 7, there's only one factor, so the exponent is 1, okay? We can have a number to the exponent of 1. It's kind of okay, just like it's written here. It doesn't really change the answer if it's to the exponent of 1 because it's just that number by itself, but it's important that we understand that it is a factor still, okay? So, just thinking of this, we want to express this as a power, and then we want to evaluate it, okay? Evaluate it means, again, we're looking for the standard form, okay? So I have 4 times 4 times 4. So I have 4 as my base because that's the number being multiplied. And I multiply that 3 times by itself, okay? So I'm going to move that just for a second here. So I have 4 to the power of 3, okay? And 4 times 4 is 16 times 4. Okay, that's going to give me 40 plus 24 is 64. So 4 to the power of 3 is 64. Here I have my base, my factor is 8. I only have one of them, so I have 8 to the 1, and that is equal to 8. Okay, here, again, exponents can be used with our with fractions. Now, you'll notice these are between brackets, okay? Really, really important. If we're going to evaluate that, I'm going to put that down here. We go 1 half. We're going to put it in brackets, and then we have 1, 2, 3, 4. So that is my exponent. If I were to write it like this, I'm going to change to red because we don't want to do this. The only thing that's being squared in this case is the 1. Or sorry, found to the power of 4 is the 1, not the 2. So this is going to make a difference later on, but right now the only thing that is being found the power of is the 1, is the numerator, okay, not the denominator. So these brackets here are extremely, extremely important, okay? So I'm going to go, that's 1/2 times a half is a quarter. So we have 2 quarters there, and I'm still going to multiply those together. Keep the brackets, okay, and that's going to equal to 1/16. Okay, so really what I'm finding is 1 to the power of 4 and 2 to the power of 4. Okay, so what I get for an answer is 1/16. In these last two, okay, we have two numbers. This one, my factor is 10, so we're going to go 10, and we have to figure out how many powers we have there. 1, 2, 3, 4, 5, 6. So we have 6 of them. Okay, when I count them, I have 1, 2, 3, 4, 5, 6. 6 of them, and then we get 100 times 100 times 100. Okay. That's 10,000 times 100, which is going to give me 1, 2, 3, 4, 5, 6, 1 million. Okay, so 10 to the power of 6 is equal to 1 million. You'll notice, and we're going to get into this in our next set of notes, that my power here, my exponent is 6 with 10. When my exponent is 6, look how many zeros I have. 1, 2, 3, 4, 5, 6. Okay. Again, my base this time is 3. Okay, and I have 1, 2, 3, 4, 5. 5, so I get 9 and 9, and then I get 3. So I go 9 times 9 times 3. That gives me 81 times 3, 243. We're going to learn, you're going to be able to do these in your calculator too, but you still have to be able to do that multiplication. So there's just some quick examples. So remember that I said that being able to, that brackets are going to be really, really important, okay? Especially when we're dealing with negative numbers. So if a power has a negative symbol, parentheses or brackets play a significant role. We need to know how to identify the base of the number before we complete the multiplication, okay? So in this case, with example 1, my exponent is outside of the parentheses, okay? We have parentheses around the -3, around the base. That means that the entire base is -3, Okay, so the base is between parentheses, so that means the base is going to be negative, okay, in this case, or it is -3. This means we multiply using the same rules as multiplying any integer. So I would go -3 times -3 times -3 times -3. Okay, so when we're doing -3 to the power of 4, we're going to get, well, we have 1, 2, 3, 4 negatives. So we have a positive number of negatives. So if I did these two together, kind of ran out of space here, but here, let's move it down here. If I did -3 times -3, I would get +9 times, and that's +9 again. So that gives me +81. So -3 to the power of 4 here gives me +81. Say I had it -3 to the power of 5 in between parentheses, because I have 5 negatives or 5 integers, okay, that means automatically my answer is going to be negative. Okay, we saw in the last example that 3 to the power of 5 is 243, so it would be -243. Now, in this next example, we have -3 to the power of 4. Now, you'll notice there's no parentheses, and this is really, really important. If you remember last year, sometimes we would be confronted with a problem that would be like -x equals 2, right? And we would say x is equal to -2. This is kind of that same idea. That negative without the parentheses is just kind of hanging out, okay? So in this case, the base is actually only 3, okay? It really is -1 times by 3 to the power of 4. Okay, so my repeated multiplication is going to be -1. We're going to throw that there, and then we're going to go times by 3 to the power of 4, which is -1 times 3 times 3 times 3 times 3. That's what it should look like. When we multiply the product of the power by -1, that's what we're going to do at the end, okay? So you're going to have, we know that 3 to the power of 4 is 81, so you're going to have, if you were to do all this, you would have -1 times by 81, which gives us a base of -3, oops, yeah, sorry, if I had -3 to the power of 4 here, I'm going to have -81. Parentheses play a huge role. Okay, now you'll notice we have this -3 to the power of 4 in here, okay? But then we also have a negative sign in front. So we're treating this, the -3 to the power of 4, the same as we did in example 2. So that is, the base is 3, okay? So in this example, we have to take what we've learned from the previous section and apply it again. The -3 to the power of 4 gives a negative product, and then we're again multiplying it by -1, so it becomes a positive product. So really, not that we would ever show this, but we're going to have -1 times -1 times 3 times 3 times 3 times 3. Again, my exponent, or my base in this case, is 3, not -3, but 3. And I'm just doing a bunch of multiplications by the negatives at the first. So these two create a positive, so then negative, parentheses, -3 to the 4 is going to be +81. Here's the fun part about this. If I had we'll do that, -3 to the 4, that's actually going to be -81. Because remember, in this case, the -3 is the whole base. So -3 to the power of 4 is 81. But once I throw that, I'll just do it in a different color here, that negative outside the parentheses, I have to multiply this by -1, which gives me -81. So, just before you kind of go into some practice and stuff, really, really important when you're putting um, exponents into your calculator, and we're going to go through this, and maybe Mr. Needleoff or can show you. When you're doing that, you want to put the brackets there. You have to have the brackets. If you do your brackets like that, it's going to give you a different product than if you did it like that, okay? That little arrow up sign, most of you will see it just above the squared sign on your calculator, but that's how we put in a power other than squared, okay? So um, on the next page, there's some questions that you guys can do. There's still some notes there, but we'll go through those in class. There's some questions that you folks can do from your textbook to start to work on that. And do your best to try and work your way through it, but just make sure that you're identifying the base before you do anything else.